Good day everyone. This is Dharni working in SRM Madurai College for Engineering and Technology. Today we are going to see about a K-map. K-map is nothing but a virtual tool used in digital logic design to simplify the Boolean algebra expression. It actually introduced in 1953. K-map are mainly used in designing combinational circuits where the output depends only on the current input, as we already know about, and we have learned this in combinational circuits. The output only depends upon the current inputs. By simplifying logic expression, K-map helps to reduce the number of gates required in a circuit, making design more efficient. Yeah. What are the uses of K-map? K-map actually used to simplify the Boolean logic by using algebraic rules that can be complex and that can be pronounced as error. And K-map always produces a systematic and faster method for simplification. For example, it used to minimize the number of logic gates and used to reduce the circuit complexity, and it's used to save a cost, power and space in digital devices. We can just know about how the basic concepts works here. The basic concepts work here is minterm, maxterm and grouping in K-map. How the minterm works here? A product and term where each variable appears exactly one, either in a normal or complicated form. For example, I have been given for A and B, the output would be A bar and B bar, comma A bar and B, and A, B bar and A and B. For the max term, how the variable is designed is a sum or term where each variable appears exactly once in normal or complicated form. For while comparing this min and max, we can able to know about in min term the product and term is used, and for the max term the sum or term is used. So the comparison here itself we can able to easily identify. And for the K-map cells, if the term is filled with 1, that's mean by a sum of product. Then if the term is filled by a 0, then the max term would be a product of sum. Here itself we can able to see for the min term we can have a AND gate, and for the max term we can have a OR gate. So while going into for a min term we are supposed to mention 1, and for max term we are supposed to mention a 0. Here in this itself we have to know that for the min term we are going to use a sum of product, and for the max term we are going to have a product of sum. And for the grouping, K-map cells are filled with 1 for the output, as we have mentioned before, and for grouping is made with a combination of one rectangular of size. For example, if the large group can be converted into a simpler expression, we can just go for a K-map grouping rules. Yeah, this is a K-map grouping rules. Yeah, group rules must be power to 2. For example, 1, 2, 4 and 8. It must be a even terms. And group must have a rectangular or square. No L shape or irregular group can be mentioned here. Only the rectangular and square shape should be mentioned here. No L shape should have mentioned there. So make the largest possible groups to achieve a simple expression. So you can just make sure that largest possible group should be available here, and each group must contain ones of SOP or zeros of POS, as we mentioned in the previous slide. Actually everyone knows about how what is the expansion of SOP, that's a sum of product, and for the expansion of POS as product of sum. So and that group can be wrapped around the edges, only the top and the bottom row, left and the right column are adjacent. Okay, so we are not supposed to map at the top to the bottom. We have to have a top to bottom rows, not the columns. Okay, and right to left columns, and each one must have include at least one. Okay, for the product of sum, each zero must have at least once. So no overlapping groups are allowed if it's be helps to simplify the expression. So we are not supposed to have any overlapping here, and you can just avoid unnecessary groups that don't contribute to simplification, as we already know about it. And I hope this K-mapping group rules have been understandable to you. We can just go for a SOP simplification example sums. Yeah, before going into it, we are supposed to have what are the types of grouping is there. For group size, one cell is one minimum. There is no simplification for that. Example, A bar, B bar, C bar and D bar. For two cells, we can have one variable eliminated. Then we'll be considering as a bar into B bar. For 4 cells, we can have a 2 variable eliminated. Then the example would be A bar. For the 8 cells, 3 variable eliminated. The example would be 1. For 16 full map, the function will be 1. We doesn't have any eliminations there. So the thing is, while simplifying the expression, how we have to group a K-map is from the left to the right of a column and top to the bottom of a rows. Yeah. This is an example problem. We are going to see it. You can just have a look on a question. Simplify the following Boolean expression using a 4 variable K-map. For example, they have given f of a, b, c, d is equal to summation of m. While seeing this summation, we have to think that this is a SOP. Okay, sum of product. If they are giving a pi, then it will be a product of sum. By seeing this question itself, we can able to easily identify what's the method of this sum. Then I'm going to draw this. See, I'm just giving a B, C, D. They are giving in the question. If they are given B, C, D, C, then we are going to suppose mention that one. Okay. Then 0, 0, 0, 0. 0, 1, 0, 1. 1, 1, 1, 1 and 1, 0, 1, 0. Then I'm just putting a inner values too. After that, if the 0 is available in the question, then I'm supposed to put 1 here. Okay, if the 0 is not available, we are not supposed to do that. Only for the available values, I'm just giving a 1 variable because it is a sum of product. It's a min term. If it is a product of sum, we are supposed to put here as a 0 value. So, okay, for this 3, 2, everyone I have mentioned, then I'm just grouping it. First, we can go about in the upper term. See, 1, 1, 1, 1. So, I'm just grouping this 3, this 4. Then I'm just going for here. I'm can able to group this, and this 1 is available only in the left column, so I'm just doing this, and this is in the right column, I'm just doing this. But why we are leaving this 1? Because we doesn't have any group value. We can't able to give a group value for this one because only 4, 2, 1 we can able to group it. So that I'm just leaving this. For the first term, I'm just giving the min term of m2 can form a 4 square. With the help of m3, m6 and m7, we can just make it as a column of a bar of c. Okay, then I'm just going for a m8. m8 can form a square of with m10 because it's forming a square with this. Okay, so then I can able to make it a term of a, b, and then here while going for d. Okay, then a, b, d bar. Okay, then I'm just going for a m13. Yeah, while going into m13, I can able to make a 2 square of m15. So that I'm just making this as a b bar of d. Okay, finally I'm just going to combine all these equations into a SOP expression. For f of a, b, c is equal to, first term is we have mentioned a bar of c plus and ab of b d bar plus and a b bar of d. Okay, I have mentioned everything in a single loop. Okay, I hope this question understands you more. Then we can have a look on product of sum. Yeah, this is a product of sum. As I mentioned before itself, summation have been given a method of sum of product, and product of sum have been mentioned in a pi. Okay, see, here we can have an answer. As the same previous sum, I have written a sum of values a, b, c, d, and I have given a box, everything. The 0, 0, 0, 1, 1, 1 and 1, 0 I have given. See, here they have been given value for 4. 4 I am just mentioning 0. In min term we are going to mention as a 1. So 4 we are going to mention 0 and 6 as a 0, 15, 14 and 11 as a 0. I am just going to have a group of first term. See, while giving using into here, this 4 and 6 can be have a group of 2 square. Okay. Then here we can go for a 15, 11. That we can have a group. And another group is going to form here what? 15 and 14. Yeah. We are going to write it. See, the max term m4 can be form a 2 square with m6. Yeah. Here m4 can be form a group 2 square with m6. That I have been mentioned a plus b bar plus b. Okay. Then the max term of m11 can form a square with m15. The same thing now we are going to have now only max term m14 is left. So m14 can have a square with m6 or m15. But we have mentioned with m15 because this term can be squared with this two and this two. But I am taking this. If you want, you can also take that. Okay. Then that equation would be a bar plus b bar plus c bar. Finally, I'm just combining all the terms into a single term for a Boolean function. Okay, for f of a, b, c, d is equal to a plus b bar plus d. This is one sum. From that, I'm going to make a product of a bar plus c bar plus d bar. From this sum, I'm going to make a product of a bar plus b bar plus c bar. So everything combined as a reduced piecewise expression for a given Boolean expression. Yeah, I hope this sum explains you more. Then we can go ahead for a summary. See, as we have been discussed in the previous one, I have given a quick notes of a summary which you can easily able to identify. For example, I have given a variable of 2, 3, 4 and 5. And number of cells would be a 2 cross 2, and for 3 we can have a 2 cross 4, and 4 we can have a 4 cross 4. And the layouts also I have mentioned. It is a highly determined function and it is a most important function which you are going to learn. From this you can definitely able to expect a one question for you. And the application of the K-map is to design a simplified logic expression, because we can't able to draw more logic gates here, so that they have identified this K-map for you peoples. And we have a practice of 4 cross 4 practice and 2 cross 2 in our classrooms. Okay, thank you so much. Thank you. I hope this understands you well.